So let's start with mixtures and alligations, right? The first concept, or rather straight on to the alligations method itself, right? So how do we use it? We'll just look at that. Alligations as a method can be used in place of weighted average to find the average, right? To find the average when there are only two terms, two items over here with some weights or frequency given to us, right? So the weights of frequency are going to be down in the bottom in the form of a ratio. And here I have x1, here I have x2, and I get an x bar. That's the mean. X2 minus x bar, as I come along the diagonal, I'm going to subtract. As I go up over here, x bar minus x1, right? It's interchanged. If you're subtracting a mean over here, the mean is going to be subtracted, mean minus the value on the other side over here, right? So you do this, and the ratio of these two terms, the differences is going to be the ratio of the weights. That's the underlying concept. I'm not going to get into the specifics of it. In case it's not too clear, just refer to the lesson to go through it in detail. But I think you should understand when we take up the examples itself, right? So the first question over here, a chemist mixes two liquids, 1 and 2. 1 liter of liquid 1 weighs 1 kg and 1 liter of liquid 2 weighs 800 grams. Okay. If half liter of the mixture weighs 480 grams, right? Two of them are being mixed over here, but their weights are kind of different, right? A full liter over here is 1 kg, a full liter over here is 800 grams. That's the difference between the two. But when the two are mixed, half a liter is nothing but 500 ml. 500 ml over here is giving me only 480 grams. What is the percentage of liquid one in the mixture in terms of the volume? So now what is asked is in percentage terms, and that's it. So what I will do is I'll either convert this to a full liter and compare, or I'll convert these to half liter and see as to what we are getting, right? So I might want to just convert these to half liter, the other two, right? So half liter over here, that is 500 ml, is going to give me 500 grams. And for liquid 2, 500 ml over here is going to give me half of this, which is 400 grams. And I just want to apply the average over here between the two. So 500 and 400 over here, when it's going to be mixed, it's going to be resulting in 480. If that is the case, just plain simple alligations, 500 minus 480 is going to be 20. 480 minus 400 is coming to 80 over here. 80 is to 20 is 4 is to 1. And 4 is to 1 is the ratio in which we are mixing L1 and L2. What is the percentage of liquid 1 in this mixture? Liquid 1 over here. 4 out of total of 5 parts. 4/5 is nothing but 80%, and this is 20%. Option 1 becomes the answer here. This looks like a question. I mean, there's a very well framed question where typically we are given percentages or concentration of something. They haven't done that. They've just told us in terms of weight what it is, right? So in terms of weight, half liter should be 500 grams. Here it's 400 grams. You mix it in a certain ratio, the average weight is becoming 480 grams, right? So for you to hit 480 grams, it should have been mixed in the 4:1 ratio, right? So if you want to look at it once again, 400 ml of this, 400 ml of the first one is going to be 400 grams, correct? And 100 ml is coming from here, and 100 ml over here is going to be 80 grams, right? 800 grams for a full 1 liter. So 400 plus 80, 480 grams is working out. 400 ml plus 100 ml, half a liter is also working out. It all adds up correctly. Yeah, so first up, an unorthodox question without the percentages to just kickstart this whole thing. Let's move to the next question. Two alcohol solutions A and B are mixed in proportion 1:3 by volume. Okay. The volume of the mixture is then doubled by adding solution A such that the resulting mixture has 72% alcohol. If solution A has 60% alcohol, then the percentage of alcohol in solution B is what? So A is given to me as 60%. B, I have to find it. And two alcohols A and B have been mixed in the ratio 1:3. That's given to me. The volume of the mixture is then doubled by adding solution A alone. So what was 1:3 over here? That's a total of 4, right? So let's write it down over here. So A and B was mixed in the ratio 1:3. That is a total of 4, right? In terms of volume after mixing it. the volume of this mixture has been doubled. So another 4 was added, but this entire 4 was only solution A, nothing of B. And we ended up with a ratio of 5 is to 3, right? So 5 is to 3 becomes the eventual ratio. That is what has been given to us in such a detailed manner, right? So given that it's going to be 5 is to 3, which is producing 72% alcohol, 5 is to 3, alligations, and I know A over here at 60%, and when I mix it up this way, I'm getting 72%. I need to find the B's value over here, percentage of alcohol over here. I have 1, 2, and the third part. The fourth can be found out. Ratio is one component. This is 1, and here is 1, and here is 1. 1, 2, 3, and 4. The entire thing is 4. Of the 4, if I know 3 of them, the fourth can be found. 60 minus 7, 72 minus 60 is coming to 12%. 12% is 3 parts. 1 part is going to be 4%. 5 parts is going to be 20%. So one is lower than the average by 12. The other should be higher than the average by how much? By 20.
92.
Yeah. The other should be higher than the average by 20 and comes to 92%. Right. So option 3 over here becomes the answer. So let's move to the next one. The strength of an indigo solution is in percentage is equal to the amount of indigo in grams per 100 cc of water. Okay. In 100 cc of water, how much of indigo in grams is there? Okay. That percentage, that's the strength. Two 800 cc bottles. Okay. 200 cc bottles are filled with indigo solutions of strength 33% and 17% respectively. Okay. Two of them. Fine. A part of the solution from the first bottle is thrown away and replaced by an equal volume of the solution from the second bottle. From the first bottle, the 33%, I am throwing away something. Okay, throwing away something out. And from the second bottle of 17%, I'm bringing in a bit and putting it into this. Fine. A part of the solution was thrown in, replaced by an replaced, right? Whatever was thrown out came in. If X went out, X came in from here. Okay, replaced from the second bottle. If the strength of the indigo solution in the first bottle has now changed to 21%. Okay. In the first bottle, after mixing it, it has come to 21%. What used to be 33%, after mixing it with 17%, right? Then what's asked over here is then the volume of the solution left in the second bottle. Both of them were 800 cc and 800 cc. X went out and X came in over here. From 800 cc, once I remove X, I need to find out what is left over in the second bottle. Just simple alligations over here. 33 minus 21 is 12. Percentage is cancelled. So 21 minus 17 is 4. Percentage is cancelled. So 1 is to 3. So these two are being mixed in the ratio 1 is to 3. The total of 4 parts over here should be 800 cc. Total of 4 parts should be 800 cc. So therefore this is 200 cc and 3 parts over here is 600 cc. So if I'm taking 600 cc of 17% solution, 600 cc from this particular one and adding here, then what is left over here is going to be only 200 cc. 200 cc is left over. Then the volume left over here is just 200, right? So once again, how is this coming to 200? Understand this 33% is left over after removing X, left over in A or bottle 1, right? As we're calling it in B1. This is what is being added from B2. So from B2, I'm taking 600 cc and mixing with the B1 of 200 cc, and I'm getting 21%. So from 600 cc has been taken out of B2. I'm left with only 200 cc in bottle 2. On to question 4. So solution of volume 40 liters has dye and water in the proportion 2 is to 3, right? So dye and water in the proportion 2 is to 3. 40 liters of total is given. So therefore, what can be done is we can split it as 16 and 24, right? 2/5 and 3/5. And this is the actual volume over here. Water is added, only water is added. And we are getting it in the ratio of 2 is to 5 over here. So 2 is to 5 is going to be the ratio. Write it a little down. That means dye comes as it is, only water was added, remains at 16 liters. 16 liters, 2 parts, 5 parts over here is going to be 40 liters, right? If that is the case, the water which was added over here was just 16 liters, which is not even required for this particular question. Because what it asks is, if 1/4 of this diluted solution is taken out, how many liters of dye must be added to the remaining, right? So it should not be to the 1/4 which is taken out to the remaining solution. If 1/4 is removed from each, what is remaining over here, dye and water, are going to be 1/4 out, 12 is left, 12 liters is left over here. 1/4 is removed from here. We have 30 liters remaining over here. To this, how many liters of dye must be added? Only dye should be added. 30 remains 30. To bring it back to 2:3. To bring it back to 2:3, 30 liters is 3 parts, 2 parts is 20. To 12, I'm going to add 8 parts over here, or 8 liters. 8 therefore becomes the answer over here. So next is alligations with parts method, right? What is the parts method over here? So here we might be given the ratio of two items which are being mixed in the ratio of 3:5, let's say, and I have 80% is the class average of A and B is 88%. The number of students in these two classes is 3:5. What is the combined average? What is the combined average? We can use the parts over here, meaning sum of parts over here. The sum equals, in the bottom, the sum is 8 parts. Above, we're going to look at the difference. Difference at the top, sum at the bottom. Difference is 8%. If 8% is 8 parts, 1% is, one part is 1%. So this 5 over here is going to be pulling it from the opposite direction by 5 parts or 5%. So this 3 over here is going to be pulling it from 88 by 3% towards 80. So minus 3%. Whichever way you look at it, you're going to get 80 plus 5 is 85%, or 88 minus 3 is also 85%. This will always be the answer. All right. So how do we use the parts? Sum of the ratio terms is going to be the parts. The difference of the values is going to be the percentage or whatever value. One part is how much. By that much, it's going to be pulling it towards the other, right, to come to the average. So this is a concept which can be used very often to answer these questions quickly. Let's take up an example over here. So a class consists of 20 boys and 30 girls. In the mid-semester examination, the average score of the girls was 5 higher than that of the boys. Okay, we have 20 boys and 30 girls. We can say 2:3 is the ratio of boys to girls. The average score of the girls was 5 higher than that of the boys. So if I say boys over here is A, girls over here is going to be A plus 5. The ratio over here is 2:3. 2:3. In the final exam, however, the average score of the girls dropped by 3, while the average score of the entire class increased by 2. Entire class. To find the average of the entire class, what do I do? The average of the entire class is going to be, take the sum of the parts over here is 5. Take the difference over here. The difference over here is A plus 5 minus A is 5. So 5 is the difference in 5 parts over here. Each part is going to be 1. I'm pulling by 3 parts from here towards this, add 3. And I get A plus 3 as the combined class average. This is the class average. Now in the final exam, the average score of the girls dropped by 3. So I have boys, I have girls. If A plus 5 is reduced by 3, I'm getting A plus 2. And the average score of the entire class increased by 2. From A plus 3, it has increased by 2 and become A plus 5. Okay. Now, what it asks me is, the increase in the average score of the boys is what? From A, what does it become? The number of students continues to be 2:3, right? So from 2, it has come to 5. A plus 2 to A plus 5 is an increase of 3. So if 2 parts was able to pull it by 3. So 2 parts over here is equal to a plus 3. Then 1 part is going to be a 1.5, half of that. So 3 parts over here is going to be 3 into 1.5, 4.5. So it's going to move it by 4.5 and go up. From A plus 2, it increases the average. From the average, should further increase to get to the next term. Add 4.5 and you get A plus 9.5. so that your average of A plus 5 is between these two values. So the increase in the average score of the boys over here is going to be option 1, which is 9.5. So alligations, when two alloys with metals in some ratio are going to be mixed, right? So you might have alloys like copper and zinc over here in the ratio 3:5. There's another alloy 2 over here, which has copper and zinc over here in the ratio of 2:7, let's say. And these two are going to be mixed in the ratio of 1:2. What are they saying? I can't be using 3:5. There are three ratios given, right? So this is the volume mixed A1 and A2. Now within A1 we have copper and zinc this way, and A2 we have it this way. So we can only do for one of the terms, either copper or zinc. Copper is 3/8 of total. Copper is 2/9 of total over here. These two are going to be mixed in the ratio of 1:2. What is this value going to be, right? For which bring 8 and 9 to the same denominator, bring it to 72 into 9 by 9 over here, and into 8 by 8 over here is going to be 72, and you get 16. And you work with it accordingly and look to solve, right? Parts you can use, the difference is 11. Again, you can multiply with 3 by 3 because this is 3 parts. We look at it in a couple of examples over here, right? So the first one, quite different actually, the way we'll be solving this, I think. If a certain weight of an alloy of silver and copper is mixed with 3 kg of pure silver, you already have an alloy of silver and copper, 3 kg of pure silver, the resulting alloy will have 90% silver by weight. Okay. If the same weight of the initial alloy is mixed with 2 kg of another alloy which has 90% silver by weight, the resulting alloy will have 84% silver by weight. The weight of the initial alloy in kgs is going to be what, right? So the initial alloy over here, what is that going to be? Now, looks looks like, you know, two equations over here, and I have a certain weight of an alloy of silver and copper over here. What I don't know are the percentages of silver. Percentage of silver is going to be X%. Pure silver is 100%. And how much kg? Let's take it as n kg. I don't know how much kg either. But when n kg of X% is mixed with 3 kg of 100%, I'm getting 90% silver by weight, whatever the weight is. If the same weight of the initial n of X% is mixed with 2 kg of another with 90% silver, right? So there's a mix over there. The resultant is this. So all we need to do over here is go in for the nx, right? In this case, I would just say go in for simple weighted average, right? It should be flexible over here. That's the first thought process, right? Plus 3 kg of 100%. So 300 divided by sum of weights n plus 3, right, over here. And this is going to come to 90%. So 90 percentages I'm not using. So likewise, the next one with the same weight of the initial alloy. So nx over here plus 2 kg of 90% silver. 2 into 90 is 180 divided by n plus 2 over here, and that's going to come to 84, right? So 84, these two are different, so therefore I'm just going to cross multiply and write down nx plus 300, you get a 270 and bring it here, it's a plus 30 equals 90n, and here I'm going to get an nx. 2 into 84 is 168, bring it here, and we're going to get a plus 12, and you get an 84n. Top minus bottom, that's going to be an 18 equals 6n, n equals 3 over here, and that's what we have to find. So option 4 becomes the answer for this question. So now we'll look at alligations when, again, these two alloys with metals are going to be mixed. Another such example, and here we don't have metals, but we have mixtures of paints A and B over here, right? So there are two drums, each containing a mixture of paints A and B. Okay, drum 1, A and B are in the ratio 18:7. The mixtures for drum 1 and drum 2 are mixed in the ratio 3:4. And in the final mixture, A and B are in the ratio 13:7. That's the final. So I know for drum A over here, sorry, drum 1 over here, where it's going to be in the ratio 18:7, I'm going to be focusing only on A. A is going to be 18 by 25. And once I mix it up and all of that, I'm going to get a value. Finally, I'm getting 13:7. So 13 by 20. I have to look at A as a portion of total. Okay. And in what ratio am I mixing the drum 1 and drum 2? That's in 3:4. So I'll write a 3:4 over here. That's a total of 7 parts. 7 parts over here. Now, I want this to be 4 parts. Okay. So I'll want the denominators to be the same first. So I can express them as something out of 100. 18 into 4 is 72 by 100. And here I'm getting into 5 for both 65 by 100. And the difference is 7 by 100. No, I don't have a 4 multiple. So I'll multiply and divide by 4. So this is going to become 288 by 400. And this is going to become multiply and divide by 4, 400 over here. And I'm getting 260. So the 288 minus 260 is coming to 28 by 400. If 28 is 4 parts, 3 parts is going to be 21. 21 by 400, the value is reduced. It now has to reduce further. So 21 I have to remove from 260 and I'm getting 239 by 400. So in drum 2, 239 by 400. So 239 of A. B is going to be 400 minus 239, which is 161. So the answer is option 1 here. Yeah. So what's being done over here is I am not trying to just directly subtract and write it. I'm trying to bring it to the standardized denominator, right? So that's one way of doing it. I'm not saying this has to be adopted. An alternative approach is going to be to directly just subtract and write it down. So in the first case, it's 18 by 25. Here, let's take it as x. And here, what we are getting is 13 by 20. So when I subtract these two, I'm getting an LCM of 100. And 18 times 4 is 72 minus 65. And that's coming to 7 by 100, right? And here, what I'm going to get is 13 by 20 minus x, right? So this is subtract, here I have to go up, okay? This is in the ratio of 3:4 as has been given. So 13 by 20 minus x is nothing but I can take an LCM and write it over here. 13 minus 20x by 20. So 13 minus 20x by 20 whole divided by 7 by 100. So into 100 by 7 equals 3 by 4, right? We can write it this way as well and simplify. Take the 7 and throw it there, you get a 21. Bring the 4 here, 20. 20 into 13 is 260. 20 into minus 20 is minus 400x. 400x equals, you're going to get 239. X is 239 by 400. 239 by 400. 239 is to 161. Total of 400. 239 is A. 239 is A. The remaining 161 is going to be B. Okay, so we've done with quite a few examples with alligations. Now we'll move to successive replacement, right? With successive replacement, the concept of formula is quite simple over here. We're going to be looking at only the non-replaced liquid. What happens in replacement, we have some amount of a mixture which is removed, and then we have pure water or pure milk coming back in. Right, so if it's going to be pure water or pure milk coming back in, that is going to be the replaced liquid. Whatever is not getting replaced, if milk and water is there, we throw that solution and we replace it with pure water. The non-replaced liquid therefore becomes milk, the other one, right? So the other one, the formula for that is going to be, right, around the non-replaced liquid, the final value equals initial value into 1 minus replacement portion, right? Replacement portion to the power of n times you're replacing. That many times it is getting reduced, right? This is the reduction, successive reduction of the non-replaced liquid, right? That's what this formula is about. Let's look at it with a couple of examples over here. A jar contains a mixture of 175 ml water and 700 milliliter alcohol. Gopal takes out 10% of the mixture and substitutes it by water of the same amount. A replacement is replaced liquid is water. I have to be focusing on alcohol over here. This process is repeated once again. So 2 times it's happening. The percentage of water in the mixture is now what? I am asked in percentage terms. I don't care about absolute value. 175 is to 700 is 1 is to 4. So which means 20% is water and 80% over here is alcohol. My formulas for the non-replaced liquid. So non-replaced liquid is alcohol over here. So the final quantity of alcohol is going to be initial quantity into 1 minus the replacement portion whole square. But what is the replacement portion? It's only 10%. 10%, 10 by 100, I can directly write over here. So 1 minus 10 by 100 is 1 minus 0.1, 0.9. 0.9 square is 0.81. 81 into 8, that's going to be 648, 64.8%. That's the final quantity of alcohol. So final for water over here is what is asked, percentage of water. It's going to be a total of 100% minus 64.8%, which comes to 35.2%. So option 3 becomes the answer here. On to the next question here. From a container filled with milk, 9 liters of milk are drawn and replaced with water. Okay. Next, from the same container, 9 liters are drawn again, replaced with water. If the volumes of milk and water in the containers are now in the ratio 16:9, then the capacity of the container is what? Now, what is the replacement liquid? Water is coming back, milk is not. From a container filled with milk, you had pure milk, right? You had pure milk and only milk, right? So, how many liters was that initially? We don't know, right? So, we don't know over there. And from that, 9 liters of milk is being drawn every time. So what we can do is we can write it as one full quantity, or if that is not clear, you can just look to use percentages and come back to that portion. So what shall the percentages be over here? So milk and water are 16:9 ratio. In terms of percentage, 16:9, 16 plus 9 is 25 into 4. So this is 64%. This is 36%, right? So while some of these is 25, I want it to be 100% into 4 for both of them will give me the percentages. So 64% and 36% are the milk and water in the final. Replace thing is water. I'm concerned about milk because my formula is built around that. The final percentage for milk is 64%. Finally, initially was full 100% because the container was filled with milk. It didn't say milk and water. From this, replacement happened. Let's call it a replacement portion. Replacement portion, something was removed. How many times it was removed? Twice. Next, from the same container, 9 liters are drawn, right? Once it was done, twice it was done, and that's it, whole square. So 64 percentage and percentage are cancelled. 64 by 100 over here. 64 by 100, I can remove this and put it over here, equals 1 minus replacement portion. So 1 minus replacement portion, RP I'll call it. Root of 64 by 100 is nothing but 8 by 10, which is 4 by 5. So the replacement portion is 1 minus 4 by 5, which is 1/5. 1/5 of the total container. But what is given to me is the quantity which was removed. 9 liters of milk are drawn. So 1/5 of the volume of the container equals 9 liters. If 1/5 the volume is 9 liters, the volume of the container is 5 into 9, 45, right? So the volume of the container is 5 into 9, 45 liters, and 45 becomes the answer here. Okay. So next up is a concept which has turned up in IFT once, and it could, if it does, it becomes very easy. When we're going to be switching simultaneously and concentrations become equal, right? In these kind of questions, we are told that there is a certain percentage, A% metal in a certain alloy, and B% of a metal, or let's say A% of iron in an alloy and B% of iron in another alloy. And there you have certain weights. You have 10 kg of this and 20 kg of this. You have to take some portion of this and some portion. You have to subtract X from here. You have to remove X from here and transfer it here. At the same time, you have to take X kg out from here and transfer it here. and the concentrations become equal, then X is going to be equal to what? AB by A plus B. Now A and B are nothing but 10 and 20. 10 into 20 divided by 10 plus 20. So it's going to be 200 by 30, which comes to 20 by 3, which is 6.67 kg. A and B doesn't really matter what they're going to be. It's just a simple one-step formula. If you want, you can adopt. It's a specific type of question if it turns up, right? Something like this. Two alloys of aluminum have different percentages of aluminum in them. We don't know what they are, A and B percent. The first one weighs 8 kg, second one weighs 16 kg. That's given to me. One piece each of equal weight was cut off from both the alloys. Equal weight has been like x kg taken, and was and the first piece was alloyed with the second, and second piece with the first. As a result, percentage of aluminum became the same, right? They become equal. So once they become equal, if the weight is asked, if it's a direct question like this, AB by A plus B, 8 into 16 divided by 8 plus 16. 8 plus 16 is 24. 24 you divide here and you get a 3. 16 by 3 is a 5.33 kg. So it becomes option 3 over here. Manual replacement in hybrid scenarios over here, right? So when the replacement is not going to be standard, like successive replacement with the same portion, all of that, or we are taking from one, putting into the other, mixing it up, and then taking from that and putting into the first, when all those are going to happen, you have to track it manually, right? We'll take up an example around that. The strength of a salt solution is P% if 100 ml of the solution contains P grams of salt. Okay. Each of the three vessels A, B, C contain 500 ml of salt solution of strengths 10%, 22%, and 32%. Right. So that means if P% is 100 ml, that means there are P grams of salt. So if I'm going to say 10% of 500 ml, 10% of 100 had 10 grams. This is going to be 50 grams and so on. Okay, I can straight away apply on this 500 ml. Fine. Now 100 ml of solution in vessel A is transferred to vessel B. Then 100 ml of the solution vessel B is transferred to C. Finally, 100 ml of solution vessel C is transferred to A. So strength of the percentage of the resulting solution in vessel A. A is asked, right? So A over here is asked. So what I know for sure is I had 10% of 50. What is the initial value everywhere? 10% of 50, which is going to come to 10% of 500, sorry, which is coming to 50 grams. Next, 22% of 500, which is going to come to 110 grams. And then over here, the third vessel over here, let's label it A, B, and C. 32% of that, which is coming to 160 grams. Now, 100 ml is what is removed everywhere, right? 100 ml of the solution is taken from vessel. 100 ml of the solution vessel A is transferred to B. So I'm removing 10 grams over here, right? Because 1/5 is removed. 100 ml, so this had 500. I'm removing 1/5. 10 is out, and 10 comes here and becomes 120. But at 120 grams, it has now become a 500 ml in terms of ml, and this is in terms of grams. Grams over here. In terms of ml, it is 500 plus 100, which has become 600. 600 ml. From this 600, I have to remove 100 now. So 1/6 is removed. I'm removing 1/6 of 20 and adding that 20 over here, right? And this becomes 100 grams. Now, from this 160, it became 160. 160, 20 was added, which is 500 ml plus 100 ml to become 600 ml, right? And it becomes 180. From this 180, 100 is being removed over here. 100 is nothing but 1/6, which is 30. I take this 30 and put it over here. So from the 500, I had removed 100 ml and I'm adding back 100 ml. I'm net position is again 500 ml. 50 minus 10 plus 30, that comes to 70. So 70 grams for 500 ml. 70 by 500 into 100% is going to be 14%. Right? Option 1, 14 becomes the answer over here. So on to the last part of alligations before we take a break. All right. Um, so last concept over here would be around evaporation. Question like that turned up in CAT 2001. But this deals with, one of the units changing, right? One of the terms changing, the other remains constant, right? Um, let's look at it. Fresh grapes contain 90% water by weight, while dry grapes contain 20% water by weight. They're not speaking about the other element. Let's call that pulp, right? That is not being spoken about. That's what we have to think about, because water will evaporate, pulp doesn't, pulp remains. If 90% is water, pulp is only 10% when it comes to fresh grapes. Dry grapes, 20% is water, pulp is going to be the remaining 80% over here. What is the weight of dry grapes available from 20 kg of fresh grapes? So if I have 20 kg of fresh grapes, if I want to split it as water and pulp, water over here is 90%, pulp is 10. 10% of this is 2. Water over here is going to be the remaining 18 kg. Now, what is the weight of dry grapes available? Now, pulp is going to remain 2 kg over here when it comes to dry grapes. That doesn't change. Water quantity is going to change. But this 2 kg is now going to become 80% of the total. If 80% is 2 kg, 20% is going to be what of water, 20 is 1/4 of 80, 1/4 of 2 is 0.5 kg. The total therefore is going to be 2.5 kg. I can get 2.5 kg of dry grapes over here from 20 kg of fresh grapes.